this short video, we would like to introduce you to underwater digital terrain modeling by remotely controlled unmanned surface vehicles, USV. We will start with short introduction to DTM modeling and review of classical techniques of UDTM data collection. Then we will do the review of USVs with single beam echo-sounder sensor. The main goal of this presentation is to show you the low-cost USV project named Batdron with the case study in Rogoźnica Gross-Rosen quarry. The digital terrain model is a very useful type of information for planning and designing of area of interests. The classical measurement technique allows to determine DTM, but underwater DTM modeling is a big challenge, not easy to measure without additional equipment. There are many techniques and sensors for underwater DTM data acquisition. The top right image shows the classical measurement of depth with leveling method. The most common geodetic technique for collecting data for DTM modeling is GNSS positioning. This technique has several limitations. The pole length. In this case, it is about 2 meters. The sensor also can be mounted on boat and integrated with sensor for pole height measurement. For example, the GNSS receiver can be joined with single beam echo-sounder. The beginning of the 21st century is the era of using unmanned boats in various measurement applications. Modern autonomous and unmanned vessels are named as Autonomous Surface Vehicles, ASV, or Unmanned Surface Vehicles, USV, and offer a variety of design solutions in the construction of the hull and the boat propulsion. Single hull, double hull, with a screw or screwless propulsion with small draft. They allow the entry into the reservoir with difficult access caused by the presence of shallow waters. Bathymetric surveys, being part of hydrographic measurements that aim at measuring the seabed topography, require adequate positioning accuracy. Hence, the use of unmanned boats in hydrography can now be regarded as the beginning of a new era in this field. The idea of bathymetric measurement is to determine the depth of the level statements relative to the water level. Classical point measurements using GPS RTK sensors for navigation and fish finder for measuring the function of measuring pole height allows mutual 3D interaction of the bottom of water reservoir and active watercourses. Depending on the size and displacement of the unmanned vessels, its equipment is of vital importance. In particular, echo-sounder transducers of single and multi-beam type. Single-beam echo-sounders, which can be used here, are small devices that usually do not require motion reference units, MRU, to determine the spatial orientation. Hence, they can be mounted on smaller vessels, whereas multi-beam echo-sounders are placed on larger survey vessels. Members of a young surveyors scientific group were able to build the USV with low-cost components, including Blue Robotics thrusters and enclosures, a remote control radio, and a catamaran hull. The catamaran hull was milled on a 5-axis CNC milling machine by Hyperboat. The first stage of the Batdron project was finished in June 2019. The boat frame was created using V-slot profiles, and the propulsion system is based on T200 thrusters Blue Robotics turbine engines. The second stage of the project was the development of a control system and GNSS navigation for navigating the RC boat. The autopilot module is based on the ArduPilot Pixel, integrated with Arduino board with Gruppner RC radio. The boat is powered by Tatu 12,000 mAh battery that provides power to the platform for about 2.5 hours. The first test of Batdron project was held in October 2019 in West Boulevard. The testing area for bathymetric measurements by Batdron was located in Old Quarry near Rogoźnica, southwest Poland. We have used the classical TLS for on-water DTM modeling integrated with Batdron USV for underwater measurements. In this project, we focused on bathymetry measurements. The first step of data collection was mission planning. The main goal was to obtain regular data acquisition in grid form, 1 by 1 meter, and to avoid potential obstacles. The results of TLS scanning was shown on the left figure. We have used this data for extracting the coastline of the reservoir. The right imagery represents the reconstructed underwater DTM from Batdron USV data. The obtained measurements data we used to create a digital bottom model and full bathymetric map of the analyzed query. Please stay tuned and check out for our new features. You may also be interested in check out for updates on fan page Young Surveyors Scientific Group.